want you to notice the difference between these two scenarios. I'm going to look on the left. First, I need to factor this. It's set equal to 0. That's great. So I'm going to factor out a GCF first. I need to ask myself, can I keep going? I could factor this. So I keep my x, bring that down, and then I have an x plus a 6 times x plus a 1. That equals 0. So now each of these will be set equal to 0, and I will get the following solutions. This will be 0, this will be negative 6, this will be negative 1. So my solutions are 0, negative 6, negative 1. You'll notice that I started with a cubed, a degree of 3, and I got 3 solutions. Often the degree indicates how many solutions you'll get, although there is one situation that isn't the case, and that is a perfect square trinomial. But we'll get to that later. I want you to notice I took a GCF out of here, and I'm going to take a GCF out of here. So I'll get x squared plus 7x plus 6 equals 0. I'll keep my 5. I get x plus 6, x plus 1 equals 0. You know, I could just divide both sides by 5, and then I'd just be left with x plus 6 times x plus 1 equals 0, because I'm allowed to divide 0 by 5. I cannot divide by 0, but I can do 0 divided by 5. That's fine. But one thing I want you to notice, over here I had an x times my binomial, so I got 3 solutions. Here I just have a 5 times a binomial times a binomial. This 5 is not going to create a solution of 0, because it's a 5. Also, I can divide it away to just get these. So the only solutions I'll have is a negative 6 and a negative 1. And notice I have a degree of 2, and I had 2 solutions. So you will need to factor out a GCF at times. When you factor out just a constant, that's not going to create a 0 as part of your solution. No, because it's a constant. But when I factor out one of the variables, oh yeah, that will produce 0. So make a note of that difference.